I would like to ask a question on frozen feed, especially for hatcheries. Some of the people here are hatchery producers, larva producers. We're worried about contamination of Vibrio parahemolyticus through frozen feed. I don't know if I read or somebody told me now that somehow you produce some information saying that basically the Vibrio parahemolyticus might be in the frozen feed but might not be active and cannot contaminate thereon the animals. And I'd like you to clarify that for me, please. Voy a traducir la pregunta para los que no hablan inglés y a lo mejor la traducción no es igual. Le estoy preguntando al doctor Lightner acerca de la posible contaminación en los laboratorios producto de alimentos frescos congelados, básicamente alimentos congelados. Si lo que yo he escuchado, ya no estoy seguro si es una publicación de él o algo que alguien me dijo, pero al final la información que tengo es que cuando las dietas se congelan pueden tener presencia del Vibrio parahemolyticus, pero no en una forma activa que no puede realmente contaminar a los reproductores, en este caso si es un alimento reproductores, pero estoy pidiendo que me lo aclare.
So Vibrio parahemolyticus does survive freezing for a brief period of time. So, but it's probably very brief. So maybe 24 hours max. So if you take it far enough down, maybe minus 20 or so, then maybe you might eliminate. But you know, it's never for sure. Never for sure. This sample that we showed up here with the Artemia biomass, I think I said Artemia biomass, I hope I did. That sample came in positive for a sample of Artemia adult biomass that also came in positive and for EMS. No, it was active. So it came in frozen, but it was still, there was still some agent there. So it's very, very troublesome.
¿Usted ha analizado animales de camarones de Guatemala y Honduras con síntomas del EMS? ¿Se podría decir que ya en Centroamérica está la enfermedad? Translate for you. Have you analyzed shrimps from Guatemala and Honduras with the symptoms of the EMS? Could you say that it is already in Central America?
Yes, I think it's here. We have seen samples, not from Guatemala, but from Nicaragua, and even here in Honduras. I'm sorry? Yes.
Si el PCR a tiempo real es altamente sensible, ¿por qué no se toma un rotundo positivo sin acudir a la histopatología? If the PCR, if real-time PCR is highly sensible, why doesn't take a positive without getting to histopathology?
We always like to couple histopathology in our lab with confirmation, just as a confirmatory step to pick up EMS positive animals, for example. So that's one of the steps that we always do, at least in my lab.
Dr. Lightner, ¿usted ha corrido pruebas del camarón de Honduras este año 2015? De haberlo hecho, tenemos EMS, se repite la pregunta, pero igual específicamente 2015. Dr. Lightner, have you run tests on shrimp in Honduras, specifically in 2015? If you have, do we have EMS?
You may have it. So that's all I can say.
Genotípicamente se ha demostrado que el EMS de Asia es diferente que el de México. Se ha determinado cuál de los dos es más agresivo. Genetically, it's been shown that the EMS in Asia is different from the one in Mexico. Has it been determined that which of both is more aggressive?
Well, they're both about the same. So if you test in a simple bioassay, if you test to see which one is more aggressive, they are the same. So there's no difference between the two.
Okay, I'm very confused in relationship with the current PCR test. There are some based in directly the primers of the AP, but also those that are based on the genes that synthesize the toxin, the PRAAP. I have read that it's recommended to use both as a more specific or more clear results. What do you think in those that we have available today are basing only one of the procedure or combination? What would be your recommendation about it? Me pregunto la siguiente, le digo que tengo dudas sobre, corrientemente se tiene disponible en las pruebas de PCR, lo que se basan en los indicadores genéticos del virus parahemolítico y lo que se basan en los genes de las toxinas, que sintetizan las toxinas del virus parahemolítico, los dos. Entonces, ha habido recomendaciones que se use los dos, la combinación de los dos. Yo le pregunto a él si se puede con uno solo o si ciertamente esa recomendación es válida de que ambos puedan ser utilizados o sea necesario utilizar ambos.
Well, we use both techniques in my lab. So we do look sometimes for PIR A and B, and we also look for the quantitative real-time PCR sometimes. We're starting to move more and more into them. So it's just more accurate, it's better. We can pick up less than 10 copies.
¿Cuál sería la ventaja de un kit PCR si tu finca ya tiene la enfermedad del EMS? What would be the advantage of the PCR kit if your farm has already been confirmed with EMS?
Yeah. If your farm has EMS, then basically you're done. So maybe you'll get 70% survival. Like I saw some piece was showing some 70% survivals, and then better survivals with Ecuadorian, some of the Ecuadorian stocks. So, but in Vietnam, where I've spent a lot of time, I looked at a lot of ponds that had less than 5 or 10% survival. So I did see quite a few ponds of that type.
Una pregunta otra vez sobre la biomasa. Si da positivo en biomasa, la toxina puede afectar al camarón vivo aunque la bacteria esté muerta.
Well, I think that the bacteria, the Vibrio parahemolyticus, that causes EMS, or acute mortality, or acute hepatopancreatic mortality disease, must be alive. Otherwise, things aren't going to work. So I think the answer to that then is that living shrimp should be exposed to the agent, maybe at 10 to the 8th, 10 to the 9th colony forming units per gram of tissue, and other, so that the agent will actually cause the disease. Okay.
In an event I went to in Mexico, one of the scientists of the CIA, he was using the hypothesis that in order for the toxin to cause damage to the HP, it was not necessary to colonize the intestine, the stomach, but they could directly from the water increase and produce the toxin type of poison and kill and affect the HP. What do you think about that theory? Do you think it's necessary the colonization of the intestine of the shrimp before it can cause damage, or that is also possible that the bacterial population grow to such level that they actually can affect without even being inside the shrimp? Mi pregunta es la siguiente. Uno de los científicos del CIAP explicaba que posible efecto de la toxina pudiese ejercerse inclusive desde fuera del camarón, desde el agua, como una especie de veneno, sin necesidad de realizar una colonización del sistema gástrico del camarón, del estómago, y de ahí causar el daño en el hepatopáncreas, y luego pues venían los efectos de la infección secundaria. Estoy preguntando qué piensa él de esa posibilidad.
I'll repeat your question, I guess. I think you have to have colony-forming units within the stomach in order for the disease to actually do its thing. So, and then you get the massive sloughing of the epithelial cells from the hepatopancreas. So you get that massive sloughing, and that's the key to the disease. So. And then the terminal phase is then you get the massive hemocytic inflammation and vibrio colonization and so on. So, but I think the key to the whole thing is that you have to have the colonization of the stomach in order for the disease to work.
Pregunta: ¿es correcto que animales infectados por EMS mejoran o superan la enfermedad introduciéndolos en estanques de agua filtrada y esterilizadas en acuarios?
At least in my lab, we don't normally see any Vibrio parahemolyticus in sterilized water. So that's one of the things we never see. Did that answer your question okay?
He escuchado que supervivientes de EMS, que episodios de supervivencia de EMS siempre darán resultados negativos en el PCR. ¿Esto es verdad? Si es así, ¿por qué está sucediendo? I've heard that survivors of EMS episodes will already test negative by PCR. Is this true? If so, what's happening?
Well, I hope it's not The issue there is whether or not they're testing negative by PCR. And I think Simon over there would be flinching about that. But I don't think they test negative.
En caso de los poliquetos, ¿tiene hecho pruebas para AMS? In the case of polycats, bloodborne, have you run any EMS tests?
What we do when we get polychaetes in from various sources, particularly in Nova Scotia and the British Isles and Denmark and so on, they're always negative. But that's the only kind of samples we ever get. So we're not always as sure of those as we are maybe other kinds of samples. But if you get live polychaetes, then occasionally, there might be an introduction of EMS. But maybe that's in Southeast Asia, Thailand, and so on.
¿Alguna otra pregunta?
It is in relation with the additive. I know that you have evaluated from different companies, different products that people said they work or they want to test if they work against EMS in your lab. Without intending that you tell me what product, will you say that you had seen in your lab result that shows that some of those additives actually can help to control or manage the infection? Sí, la pregunta es en relación con aditivos. Cuando se presenta este tipo de enfermedades vamos a ver todo tipo de promesas de diferentes compañías que muestran que todos los aditivos que ellos venden son milagrosos y curan y son la solución del problema. Yo le pregunto a él porque él ha hecho muchos análisis en su laboratorio de estudios privados que las compañías guían sus aditivos. Le pregunto si él, sin decir el nombre de aditivos, si él ha visto que algunos de esos productos realmente funcionen en los ensayos de reto que ha realizado en su laboratorio.
Just to repeat your question, I think it was about quantitative PCR?
No, the additive.
Oh, the additives. Okay. Well, we haven't found any yet that actually work. In my lab. Now, once in a while we'll find like a probiotic that might have some benefit, but for the most part, we haven't seen anything that really works. Shrimp shield, a number of things, just at least when we run a challenge study, they don't work that well. So we get essentially 0%. Less than 10% survival.
Dr. Lightner, we have seen in tests that when Vibrio paremolyticus hits a larval tank, for example, the exponential phase can get pretty mean and you do get heavy mortalities. But then, at least in the case of the samples that we tried, there was survival, even with a very, very massive amounts of Vibrio paremolytico. I think the survival was about 30% in the worst scenario. But the question really is that after that, we couldn't find the Vibrio paremolyticus. There was none left in the tank or in the survivors. It was like it disappeared. And not being an expert, I'd like to ask you if that is a possibility and how that mechanism could cause the disappearance or not being able to find the Vibrio paremolyticus anymore. I'll say it in Spanish now. La pregunta que le hago es, nosotros hemos hecho pruebas para evaluar el Vibrio paremolytico en tanques larvales y averiguar cuán letal puede ser el Vibrio paremolytico en esa condición donde la cantidad es muy elevada, 10 a la 9, 10 a la 10, y la supervivencia en el peor de los escenarios llegó a ser 30%, o sea, no mató todos los animales, pero lo que realmente nos sorprendió es que no podíamos encontrar el vibrio parahemolítico cuando la mortalidad había parado, desaparecía. Entonces la pregunta que le hago a él es si eso es posible o es que estábamos nosotros no siendo capaces de encontrarlo, y si es posible que desaparezca del todo, ¿cómo es el mecanismo? O sea, ¿qué es lo que sucede? Y no le pregunté, pero la pregunta se la voy a extender a si eso también puede ocurrir en un estanque de camarones. And to the extension of that question would be if that could also happen in a regular farm, on a pond, the disappearance of the vibrio after the mortality.
Again, in my lab, once in a while we find at about maybe 30 days post-infection that the vibrio parahemolyticus disappears. So I think that, you know, your observation is probably right on. So that it does, eventually it does disappear.
So could it happen in the pond?
Well, pond is, we don't work with ponds that much at the University of Arizona. So I don't know the answer to that.
And what causes it? What's the mechanism?
Well, I think that the mechanism is that other vibrio species outcompete the vibrio parahemolyticus, and it just causes it to go probably down to almost zero. But you know, you can still find vibrio parahemolyticus in some of the samples.
So a follow-up question would be, if the mechanism by which vibrio parahemolyticus finally disappears, comes in the medium, or at least we can find it, if that is by displacement of all the vibrios, then could you translate that, or could you have an inference that we might be able to also displace it by the use of a lot of probiotics before it actually takes over? That, in other words, that would prove, would that prove that the use of probiotics could effectively displace the vibrio parahemolyticus to the point that it doesn't allow it to grow to cause damage? La pregunta que le hago, siguiendo la explicación de él, de que la probabilidad de que la desaparición del vibrio parahemolytico posterior a un ataque masivo, al desaparecer, él comenta que lo más probable es que haya sido por desplazamiento de otros vibrios, buenos, malos, no sé, pero de otros vibrios. Entonces yo le hago la pregunta de si eso no nos daría a nosotros una luz de que los probióticos en un momento dado, usados preventivamente, pudieran desplazar de manera efectiva el vibrio parahemolytico que está causando la mortalidad antes de causarlo. En otras palabras, que sería realmente algo, una herramienta importante de trabajo para todos nosotros, trabajar con probióticos efectivamente.
So, getting back to what your question was, so freezing, is that what it was?
No, I went back and said, if the vibrio parahemolyticus disappear
Okay.
by displacement of all the vibrios,
Oh, all right.
whether that could also fear that using probiotics would also prevent
Oh,
the
okay.
growth of in an effective form. As a tool.
In farms. Yeah. Well, I did visit a few farms in Vietnam and some in Thailand, but I don't think most of the time you'd see a very high mortality, and so EMS of 10-20%. But the EMS, eventually it's going to disappear. I believe that that's the case because, at least in my laboratory, we don't see it after about 30, 40 days. So I think it probably disappears, but you can still find it if we test by quantitative PCR, for example. We can still find the toxin gene.
Yeah, but the question is whether you could displace the microbiome before it becomes a problem, as opposed because you know that it will disappear by displacement. So the question is whether we can do this preventively. Is that the same thing?
I don't know. I just don't know the answer to that. Maybe you could.
What is your intuition, Kelsey? You got a bunch of producers that need our help.
Yeah. Well,
Who kill you if you're wrong?
yeah, well, I don't know the answer. I really don't know. Sorry, but I just can't answer. Because we don't work with ponds. I did some work in Vietnam and so I visited a lot of farms, but in Thailand. But that's all. That was all I did that summer. Usually.
Repeat the question. Ella preguntó si ha visto algunas granjas donde los probióticos funcionan. Dice no.
No, we haven't seen any probiotics that are up to the advertisement that they come with. So we just haven't seen that many. Well, tilapia, tilapia have a very interesting ecosystem because they generate chlorella, and so with tilapia generating chlorella, that changes the total environment. So it's very really interesting situation particularly with tilapia. Is that what you